अरे नहीं सर। Hello, beta. Good morning, everyone. Can you hear me and see me loud and clear?
Yes, sir. Good morning, loud and
Sir,
clear.
good morning.
Okay.
Yes, sir.
Loud and clear, sir. Good morning.
Okay. Good morning. Good morning, everyone.
Good morning, sir.
Okay. So, beta, yesterday we had discussed about a very important concept. That is the concept of current. We discussed the terms like dead reckoning position, estimated position, a fixed or a observed position. Then we saw how the current effect is allowed for, or current effect is taken into account by making a vector triangle. So we made a vector triangle. One of the vectors was CTS, course steered vector. Another was the set and drift of the current. And then we found out our course made good vector. So that's what we had done yesterday. Also, I had covered up celestial position lines with you. So before we proceed ahead further into the effect of current and also the effect of wind, any doubt and queries in your mind before starting? Okay, all clear?
Yes, sir.
Okay, very good. That's great. So do you want to repeat the making of the course, distance and current vector triangle, or
Oh, sir.
are
No,
you
sir.
okay? So you are pretty comfortable with what was done yesterday, and we can
Yes, sir.
proceed ahead from there,
The
right?
current always in the direction which is mentioned on a paper. Just that. Current is always in the same direction, never upwards. It's like this.
Right. So tell me one thing, when you are allowing for the current, is it applied first or last?
कोर्स को स्टेयर दिया हुआ है तो करंट को अलाउ करेंगे और एंड पे अलाउ करेंगे। कोर्स में गुड में करंट को काउंटर करेंगे और इनिशियल पॉइंट पे काउंटर करेंगे।
यस सर। CTS दिया तो सर बाद में लगेगा, CMG दिया तो पहले लग जाएगा।
Very good, very good. So it's good to see you guys responding fast. Very good, beta. So everybody is clear about this, beta?
यस सर।
Okay.
Yes, sir.
As I told you yesterday also, this is a very important concept. क्योंकि चार्ट वर्क के कोई भी सवाल हमें मिले, हमारे जो पेपर का पार्ट ए है, दैट्स फॉर द चार्ट वर्क क्वेश्चंस. So any question you get on chart work, this concept more or less gets factored in that particular question. So this should be very clear in your mind. There should be no doubt about it. So let's proceed ahead now. You are clear about making the vector triangle. How the triangle is to be made if course steered is given to you, that is known as allowing for the current, and how the triangle is to be made when the course made good or the destination position is given to you, that's known as counteracting the current. So let's proceed ahead now, strengthen these concepts which we have done, and also understand the effect of the wind. So that's the plan for today. So let me open up the video for you. Just give me a minute. Okay, so this is what we had done yesterday, beta. We had done up to here. So the upper triangle which you see, the black color triangle, is the one where core steered is given to us. So you see the AB is the core steered vector and B to C is the current vector. They are represented by their proper symbols. Core steered is represented by a single arrow. These are the same symbols which we had done in our first session in chart work. The current is represented by 3 arrows. So you can see the 3 arrows put here. And once we apply these two vectors, we reach to our destination position. That's the C position, Charlie position in this particular case. And alpha to Charlie, A to C is our course made good vector. So in the second case, if initial and final positions are given to you, that means the course made good and distance made good is already known. In that case, we first apply the current. So you see the current vector applied first, shown with 3 arrows, and the CTS vector is then found out. Once you have the current vector applied, you have this D point here on your chart. The destination position is known to us, that is the C point, Charlie point. So if you join D to C, this delta to Charlie CTS vector, and it can be easily read out from the chart. So we are proceeding ahead now, going little further into this, strengthening the concept of allowing for the current and counteracting for the current, and also discussing about wind.
Obviously, then A, B, and DC are parallel to each other and also equal in magnitude. So obviously, since it's a parallelogram, therefore, D to C represents the CTS and D to C distance represents engine distance in 2 hours. So the CTS is 070 degrees true, engine distance is 22 miles in 2 hours, giving us a engine speed of 11 knots. So in chart work, if we have CMG and we have to get the CTS, we would draw the current at the starting point of the CMG line and draw the triangle as the lower part of the parallelogram represents. Now, these two scenarios, one wherein we had drawn the triangle, which is representing the upper part of the parallelogram, and the one representing the lower part of the parallelogram, these are two different possible scenarios at sea, and accordingly the processes carry different names. One possibility could be that we are given the course to steer and we have to find the CMG. When the CTS is known and CMG is to be found, we refer to that as allowing for current. And whenever we have to allow for current, the triangle would be completed as represented by this triangle in the upper part of the parallelogram. That means we'll draw the CTS track, and at the final end point of the CTS track, or if you want to call it as the DR position, we shall be drawing the current at this point and completing the triangle as we had seen earlier to get the CMG and the DMG. The other thing could be that we are given the CMG and we need to find the CTS. In such a scenario, we call it as counteracting current. And when we have to counteract the current, the triangle shall be drawn as the triangle in the lower half of the parallelogram. When CMG track is given, the current will be drawn at the starting point of the CMG line. It will be drawn at the starting point of the CMG line, and the triangle will be completed as in the lower half of the parallelogram. So this is the difference, how the triangles are completed. One for allowing situation, other for the counteracting situation.
Okay, Peter, I would recommend just take a screenshot of this particular diagram and keep it safe with you. This will help you to clear out any doubts which you may have later on when you are doing these practical questions on the chart.
Done, sir.
Okay, beta. Great. Let's continue.
How the triangles are completed, one for allowing situation, other for the counteracting situation. Now, there can also be situations wherein on ship, a vessel wishes to estimate the current that the vessel is experiencing, or in exam, the current set and rate is to be calculated. If you look at this triangle, vector triangle, which we are already familiar with now, if you see current is the vector joining the dr position to its fix. It's the vector joining the dr position to the fix. So as you can see in the vector triangle, direction from dr to fix is the set of the current. So in this triangle, you can see the direction from fix to dr to fix is the set of the current, and the magnitude of this vector, or the distance from dr to fix, represents the drift of the current during the interval for which the triangle has been made. Again, it's being repeated here that every vector of the triangle has to be for the same duration. So if this triangle was made for 2 hours, so this drift of 7.6 miles would be for 2 hours. That means the rate of current would be 3.8 knots. So we need to be very, very careful about this also, because this is part of some questions wherein they would expect us to calculate the set and rate of current. That means in such scenarios, we'll have to find out the dr and fix of the same time, and using the dr and fix, we can find out the set and rate of current.
Okay, so beta, this is also clear, finding the set and drift or set and rate of the current.
Yes, sir.
Okay, very good. So in these questions, beta, where they want you to find the set and rate or set and drift of the current, they will tell you the course made good as well as the distance made good, or they will give you your final position. So you will be able to plot the red color vector, that is the CMG and DMG, course made good, distance made good vector. They will also tell you what course was the ship steering, and they will give you the engine speed or the engine distance. So these 4 items will be provided to you: course made good, distance made good, CTS, and engine speed or engine distance. So with these 4, you will be able to find out the DR, that is at position Bravo, and the fix, which is at position Charlie. Once these 2 are known, we know that the current vector is basically from the DR towards the fix. So this vector from the DR toward the fix is our current vector. So this tells us the direction, tells us the set of the current, and the magnitude or the length of this vector as measured from the chart gives us the drift of the current for the required period. So some of the questions you may have the question put like in this format.
Now let us appreciate the elements of the vector triangle, because a good understanding of the vector triangle will solve many of our problems. Let's review once again the 3 vectors involved in our vector triangle. The 3 vectors involved in our triangle are track through water, represented by CTS, and engine distance, which in this triangle is represented by AB. So AB is the track through water, represented by CTS and engine distance. Second vector is the current vector, represented by set and drift, represented by BC in this case. And the third vector is track over ground, represented by CMG and DMG, which is represented by vector A to C in this diagram. CTS vector represented by 1 arrow, current vector represented by 3 arrows, and course made good vector represented by 2 arrows. It's imperative that in this vector triangle, every vector has to be for the same duration. So whatever is the duration of one vector out here, all the vectors will have to have the same duration. Now, since there are three vectors, each having a direction and magnitude, there shall be 6 elements of the vector triangle. These elements are course to steer, engine speed, from which we get the engine distance, set and rate of current. From rate, we get the drift of the current, CMG and SMG, from wherein you get the distance made good after you integrate them with time. To be able to complete the vector triangle, please remember, you need to have minimum 4 elements out of 6. So if you have to complete the triangle, please source 4 elements, minimum 4 elements, and then only the triangle can be completed. If you do not have 4 elements, then no way can you be completing the triangle. The missing 2 elements can be then read off from the completed triangle. What is the physics law used in this vector triangle? The physics law used in this vector triangle is triangle law of vector addition, which states that if the 2 sides of a triangle taken in the same order or same direction represent 2 vectors, then the third side of the triangle taken in the opposite direction represents the resultant of the 2. So if you see here, CTS and current vector, they are in the same order or same direction because both are clockwise. And the CMG vector is anti-clockwise. It's the third side of the triangle taken in the opposite direction. So the resultant of track through water and the current is the track over the ground.
Okay, so beta, a very important thing to note and understand here is that for making this course, distance and current vector triangle, we require minimum 4 elements out of the 6 total elements which we have. See, the 3 vectors have their 3 directions and the 3 magnitudes. Directions are course steered, course made good, and set of the current. The magnitudes are engine distance, distance made good, and the drift of the current. So there are total 6 elements in this particular triangle. Now to complete or make this triangle, we require minimum 4 elements. These could be any 4 elements. Okay, any 4, I mean, let's say for example, they can give you CMG and DMG. They can give you CTS and engine distance. So 4 elements are given. The 2 missing ones are the set and drift of the current. It can be found. Okay. Or they can give you CTS, engine distance, and set and drift. 4 elements given. And you can find out the missing 2 elements, that is the CMG and DMG. So any 4 elements can be given to us in the question. And if they are provided, we will be able to find out the missing 2 elements. So any doubts in this particular slide, beta, up to here? Okay, very good. So let's proceed ahead now.
Now let us understand wind and its effect on the ship's track. Wind is a continuous directed flow or movement of atmospheric air because of different atmospheric pressure over different regions. Direction of the wind, the direction from which it comes. That is, northerly wind means wind is blowing from north towards south. So please remember, the convention used for naming the direction of the current is opposite to the convention used for naming the direction of wind.
Okay, so beta, can you tell me if I have a southerly wind, is the wind coming from south or going to south?
Wind
Coming
always
from south.
Very good. The wind is coming
Wind
from
is
south.
always from the direction and current is to the direction.
Very good. And if I say I have a southerly current affecting me, that means?
Sir, it is setting to the southerly side. Sir. It is
Current is 180 degree.
Very good, beta. So wind always comes from and current always goes to. So that is the direction of the wind and the current. You should be careful. Their nomenclature is opposite to each other. Wind is always named from the direction from where it is coming, and current is always named in the direction in which it is setting, or it is taking you, or it is drifting you. So let's proceed ahead now.
Wind affects the ship's track through water as well as over the ground. The track through water allowing the effect of wind is referred to as effective course or leeway track. So once we allow for wind on the course that the ship is steering, the track that you obtain will be referred to as effective course track or the leeway track.
Okay, beta, till now we have seen two courses. One was course to steer or course steered, that was the CTS. Second was course made good, which we refer to as CMG. It is also sometimes called as course over ground. So अब ये तीसरा एक कोर्स हम लोग यहाँ पे देख रहे हैं, that is the effective course. इसी effective course का जो दूसरा नाम है वो है leeway track. So when wind is affecting us, the track which is made through the water after allowing the effect of wind is known as the effective course or leeway track. So we will make a diagram now, and we will see the difference between CTS and the leeway track.
Angle between the course to steer track and the leeway track is referred to as leeway. In chart work, effect of wind on ship speed is intentionally left out because of limitations on number of elements of the vector triangle.
Okay, so this is also clear, beta. Up to here, any doubt, any query in your mind? Very good. So this is also important point, beta, the last one. The effect of wind on the ship's speed is intentionally left out because of the limitation on number of unknown elements in the vector triangle. So as far as chart work is concerned, we do not consider any effect of wind on the speed of the ship. Though practically it is possible that wind may have some effect on the ship. So if the wind is coming from stern, it may lead to little bit increase in speed. If the wind is coming from right ahead, it may lead to a little bit reduction in the speed. But as far as chart work is concerned, we only consider the effect of the wind on the course. No effect is considered on the speed of the ship.
सर बेसिकली ये सब कुछ हम काउंटर करके जो CMG की स्पीड आती है उसी में ले लेते हैं. सर जैसे जो भी इफेक्ट आया, जो भी सब कुछ हुआ, सब लगने के बाद ही जैसे CMG बनेगा ना, तो सर उसी में इसी में ले लेते हैं ना इसको सब, मतलब जितना भी जो भी जितने फैक्टर एक्स्ट्रा जो कुछ भी लगा वो सब कुछ CMG में आ गया ना, इंक्लूड करके.
That's right, beta. That's right. The ship is steering a particular course. Wind is affecting the ship. The current is also affecting the ship. इन सब इफेक्ट्स के बाद जो हमारा रिजल्टेंट ट्रैक या रिजल्टेंट कोर्स और स्पीड निकल के आता है, that is taken care of by the course made good and the speed made good. So all these factors are included in the course made good and speed made good.
अब सर अभी तक CTS पे करंट अलाउ कर रहे थे तो CMG आ रहा था, एंड अभी जब CTS पे पहले विंड लगाएंगे तो we will get the leeway track.
Yeah, that's right.
And then, sir, at leeway track, we will put allow the current to get the CMG.
That's right. That's right. We will see on the chart, beta. What you are saying is exactly right. अभी हम इसको चार्ट पे देखेंगे.
However, practically, it may not be of much concern for the simple reason that very seldom would we have wind alone and no current. Because if the wind blows over the surface of sea for some time, the least it would give rise to are the frictional currents. So when wind and current often coexist, so even if the effect of wind has not in isolation been considered, it will automatically show up when the current is estimated, and as far as the ship is concerned, it will be taken care of. So that is if they coexist. However, if you talk of a hypothetical situation where there is only wind and no current, then yes, the effect of wind on the speed of the ship in chart work is intentionally left out. But again, I would say in practical considerations, it may not be a serious omission. Allowing wind is the term used when we know our CTS and we are required to find our effective course or the leeway track after factoring in wind. How do we allow for wind? Let us see it through a simple illustration. The vessel is at position X, is steering a course along XY track, experiencing wind which is southerly as shown by the wind arrow. Now we have to allow the given leeway. Now the leeway, when you allow for wind, the leeway must be allowed to the lee side of the vessel or should be allowed downwind, whichever way you are convenient, it's comfortable for you to remember. Now in this case, the wind is blowing from the starboard side of the vessel. So the port side of the ship is the lee side, or the starboard side is into the wind side and port side is the downwind side. So whichever way you are comfortable, you may remember it. So in our case, the leeway shall be applied downwind as shown in the diagram. This is applied on the downside or downwind side or lee side. And this track XZ that we are getting is the effective course or the leeway track.
Now, beta, the direction of the wind and the leeway angle, both these are given to us in the question. Both these things are provided to us in the question itself. They will give us which is the direction of the wind and what is the leeway angle, whether it is 1 degree, 2 degree, 5 degrees, whatever. So once we know these two, the wind direction and the leeway angle, we can apply it in this particular way and we can get our effective course or leeway track. So up to here, any doubts in the mind?
No, sir.
Very good, beta. Now, one thing is that whether the leeway angle is to be subtracted or added, it is determined by the direction of the wind. So you may have to make a rough diagram or so on your answer sheet to find out whether leeway angle is to be added or subtracted from the course steered to get the effective course. Like in this particular case, which you are seeing, we have southerly wind. So in this case, let us say if the vessel was steering 090 and the leeway was 5 degrees, what will be the effective course?
085.
085.
Very good. So the effective course would become 085. You see the leeway angle is subtracted here. But in this case, if the wind was not from south, but from north, we had a northerly wind. So in case of northerly wind, what will be the effective course in that case?
095.
Right, very good. So if you were steering 090, the leeway angle would be added in that particular case and your effective course would become 095. So you have to carefully see the direction from where the wind is coming and apply the leeway angle accordingly.
Sir, in both these cases, we are allowing for the wind, but what if we want to counter the wind?
Okay, let's counteract. We will do it now.
The magnitude of this leeway track shall be engine distance, which in the absence of wind was the magnitude of the CTS track.
So as we had discussed earlier that we do not consider any effect of the wind on the speed of the ship. So that's why the magnitude of the effective course or the leeway track vector remains same as we had for the course steered vector, that is the engine distance in this particular time. So the direction is found by applying the leeway and the magnitude is the same as the engine distance.
Yes, track. Counteracting wind shall be the scenario in which the effective course track or the leeway track is known to us and the CTS is to be found. Let us say the vessel is at point X and X to Z is the effective course track or the leeway track. Magnitude of this vector shall be the engine distance. The wind experienced is southerly as shown by the wind arrow. And now we have to get the CTS. So the leeway has to be counteracted. When counteracting, leeway has to be drawn on the windward side or into the wind. In this case, the starboard side of the vessel is the windward side, and therefore the leeway is factored as shown. And as we draw the leeway into the wind, the vector that we get XY is the CTS vector, and course to steer shall be represented by XY.
So this is counteracting of the wind beta. Is it clear now?
Yes, sir. Yes, sir.
Right. Very good. So in case of counteracting, the leeway angle is applied on the windward side. And in case of allowing for the wind, the leeway angle is applied on the leeward side or the downwind side.
Now, if we have a situation in which we have to factor in both wind and current.
Okay, now we are going to discuss beta. We have seen allowing for and counteracting the current, and we have seen allowing for and counteracting the wind. So in दोनों को हमने separately देखा है. Now we will see that if in a particular question both of them are given to us, how do we apply them? Can they be applied in any way we like, or any specific order is to be followed? So this is what we are going to see now.
Then there are few questions we need to ask ourselves before we proceed with the plotting. Question number 1, is it allowing for or counteracting? If CTS is given, CMG is to be found, it is allowing for. And if CMG is given, CTS is to be found, it's counteracting.
So beta, counteracting and allowing is clear in your mind now?
Yes, sir.
Okay, very good.
When allowing for, we ask ourselves what to allow first. In the allowing case, we first allow for wind followed by current. Let us see how we allow each of them. Through this illustration, the vessel is at position X. He's steering a course represented by this light blue course to steer vector on the chart. Vessel experiences southerly wind represented by the wind arrow. And now we allow for wind. When we allow for wind, we know it has to be allowed on the lee side. So we allow wind on the lee side, and what we get is the leeway track or the effective course track. On this track, we cut off engine distance, mark of engine distance for the interval for which we intend making the vector triangle. So the magnitude of this vector shall be engine distance, and this vector is represented by single arrow, and we reach point Y. Now we have to allow for current. When we allow for current, we have already learned current will be drawn at point Y, and drift of this current shall be for the same interval for which the engine distance was taken, and that brings us to point Z. Point Z is the position of the vessel. X to Z becomes course made good and distance made good track, and it's represented by 2 arrows.
Okay, so this is allowing for the wind and the current. Important thing to remember is that we always allow for the wind first, get our leeway track or effective course, and then in the second priority or second sequence, we allow for the current. So any doubt up to here, beta?
No, sir.
Very good. Let's proceed ahead.
So now we see in this triangle, we have the leeway track with magnitude as engine distance. We have the current track, and we have the CMG DMG track. This is how we allow for both wind and current. When factoring in both wind and current, we determine that they have to be counteracted. That means CMG is known and CTS is to be found. Please remember, we need to first counteract current, followed by wind. And how do we counteract them? Let's learn through this simple illustration on the chart.
Okay, so beta, now in counteracting, you see the order is reversed. So when we are counteracting, we will counteract the current first and the wind later. So this is the sequence which we follow. Let's see it on the chart now.
The vessel is at position X. It needs to reach point Z in a certain time. So XZ represents CMG and DMG track, represented by 2 arrows. We first counteract current, and we know when the current has to be counteracted, it has to be drawn at the starting point of the CMG line. That means X. We draw the current here. We represent with 3 arrows, mark of drift for the same interval for which the DMG is there on XZ, and we obtain this point Y. We join Y to Z, and YZ represents the effective course track or the leeway track, and the magnitude of this vector represents engine distance in the duration of the vector triangle. This effective track or the leeway track is represented by 1 arrow. Now we come to counteracting of the wind. Wind experienced, if it is southerly, represented by the wind arrow. Then to counteract wind, we allow the leeway, or we draw the leeway rather, we draw the leeway into the wind or to the windward. This is how the leeway will be counteracted into the wind, and the track that we obtain is the course to steer track.
Okay, so beta, this is how we counteract for the current and the wind. So when we counteract initially for the current, we get the effective course or the leeway track in our triangle on the chart. And once we have the effective course or leeway track known to us, we can now counteract the leeway easily. We can apply that leeway angle, adding and subtracting it, and we will obtain our course steered or course to steer. So
Sir?
have a बोलो बेटा.
और ये जो 2 कोर्स स्टेयर्ड है इस पे एरो नहीं लगना?
बेटा इस पे भी एरो सिंगल एरो ही लगता है, लेकिन जब हम one extra thing which I am going whenever we make this plot on the chart, we usually do not show the leeway angle and the course steered on our chart. So
Okay,
what we do is we find out the effective course from the chart or the leeway track. We read it out from the chart, write it in our answer sheet, and then add or subtract the leeway angle to get the CTS on our answer sheet only. We usually do not show the leeway angle and the course steered in this particular case, that is in case of the wind. We do not show these two items on the chart. The reason for this is that this leeway angle is very, very small. It could be 1 degree or 2 degree or 3 degrees. Here for illustration purpose, we have made it quite bigger, but actually the leeway angle may be 1 degree. So if it is so small an angle, you will see both these lines, effective course and CTS, will be very close, making the plot a little complicated to understand. So that's why leeway and the course steered is not shown on the chart plot, but calculated on our answer sheet. So we add it or subtract it on our answer sheet to get the CTS.
Okay sir, thank you.
Okay.
सर ये दोनों केस में हमने दोनों चीज अलाउ किया, लाइक विंड भी अलाउ किया और फिर करंट भी अलाउ किया. सेकंड केस में दोनों काउंटर किया, बट अपोजिट होगा तो एक चीज अपोजिट हुई तो
मींस एक को अलाउ करना है, दूसरे को काउंटर करना है.
हाँ सर, ऐसा केस होता है क्या?
नहीं बेटा, वैसा केस नहीं आएगा, बिकॉज अगर अलाउ करना है तो आपको CTS दिया जाएगा, and if you have CTS you cannot counteract in that particular case. और अगर counteract करना है तो आपको CMG दिया जाएगा, and you cannot allow in that particular case. So both will be either allowing or both will be counteracting. It will never happen that you allow for one and counteract the other.
ओके सर.
ओके, और बताओ बेटा, और कोई डाउट्स आ रहे हैं माइंड में?
नो सर.
सर एक डाउट था.
हाँ बोलो बेटा.
पर वैसे अभी आउट ऑफ स्पेस, जैसे ये हम इधर इंजन डिस्टेंस लिख रहे हैं, स्पेशली अगर इन जनरल इंजन डिस्टेंस देखें तो वो तो हम वो डिस्टेंस ओवर ग्राउंड हो गया ना, स्पीड ओवर ग्राउंड हो गया, तो इसमें वेरी नहीं करेगा या फिर हम कैलकुलेशन पर्पस के लिए ऐसा रखें?
ये बेटा, योर वॉइस वाज नॉट वेरी क्लियर, कैन यू रिपीट स्लोली अगेन? बीच में थोड़ी डिस्टरबेंस आ रही है.
सर ऐसे यहाँ पे इंजन डिस्टेंस मेंशन कर रहे हैं. इंजन डिस्टेंस तो सर वो डिस्टेंस ट्रेवल ओवर वाटर होगा ना?
यस दैट्स राइट बेटा.
तो हम इधर कैलकुलेशन पर्पस के लिए कर रहे हैं या फिर इंजन डिस्टेंस जब हम जनरली शिप पे चल रहे हैं हम तो उधर से जीपीएस से जितना भी डिस्टेंस ट्रेवल किया है वो डिफरेंस नहीं आएगा सर?
Okay, the GPS distance what you get is basically the distance made good or the distance over the ground. अगर हमें इंजन डिस्टेंस शिप पे हमें चाहिए तो बेटा ये हमें डॉपलर लॉग या EM लॉग, जो भी लॉग हमारे पास है, वहां से इसे रीड करना पड़ेगा, एंड दैट लॉग शुड बी ऑन वाटर ट्रैक.
नहीं वो सब तो सर क्लियर आउट है, वो तो मेरे को पता है, पर हम इधर चार्ट वर्क में इंजन डिस्टेंस और स्पेसिफिकली इंजन डिस्टेंस मेंशन करते हैं. व्हाई डोंट वी ओनली मेंशन डिस्टेंस ओनली? स्टार्टिंग से आप इंजन डिस्टेंस पर्टिकुलरली मेंशन कर रहे हैं.
Your question is that why are we mentioning it as engine distance?
Correct.
Because beta this has been covered using our engine speed.
So in that way sir हमें तो जो ऊपर जो ब्रिज पे मिलता है, जो भी हम चार्ट वर्क करते हैं उधर तो हम ओवर ग्राउंड लेते हैं.
नहीं बेटा, अगर हम ये काउंटर एक्टिंग और अलाउइंग अपने ब्रिज पे भी करेंगे और डू इट एनीवेयर इन द एग्जाम और प्रैक्टिकली ऑन द ब्रिज, अगर इस चीज़ को हम ब्रिज पे करेंगे तो हम यहाँ पे इंजन डिस्टेंस ही लेंगे. मीन्स आइदर इट विल बी फ्रॉम द लॉग और इट विल बी फ्रॉम द आरपीएम, इंजन आरपीएम के अगेंस्ट जो हमें स्पीड टेबल दे रखा होता है. सो यू विल पिक अप द डिस्टेंस फ्रॉम देयर, क्योंकि जो जीपीएस से डिस्टेंस हमें मिलता है दैट इज इनकॉर्पोरेटिंग द इफेक्ट ऑफ करंट एंड द विंड. ओके बेटा, इज इट गेटिंग क्लियर?
नहीं सर, फिर तो अगर आप लॉग से बोल रहे हैं, लॉग से भी ग्राउंड का मिल जाता है ना, ग्राउंड का डिस्टेंस.
That's why I said that when you pick it up from the log, it should be on the water track mode.
Just to avoid सर, हम सेट एंड ड्रिफ्ट अवॉइड कर रहे हैं करंट बेसिकली, देन वी अप्लाई इट लेटर. यही है रीजन सर.
Actually, I'm not able to understand your query. Doubt कहाँ पे आ रहा है बेटा?
डाउट ये है, व्हाई आर वी यूजिंग इंजन डिस्टेंस? अगर हम नॉर्मली अभी प्रैक्टिकली करते हैं तो हम इंजन डिस्टेंस क्यों, हमें तो ऊपर ग्राउंड का मिल रहा है ना, हम पॉइंट ए टू बी गए, हमारा मे बी इंजन डिस्टेंस 10 हो बट एक्चुअल में वी ट्रैवल 12 या 11 व्हाटएवर.
ठीक है बेटा, अब सबसे पहले तो आप इस पे आ जाओ. इंजन डिस्टेंस को हम लोग तब यूज़ करेंगे जब हम अलाउ करेंगे. ठीक है, काउंटर एक्टिंग में तो हमें इंजन डिस्टेंस को फाइंड करना पड़ेगा ना. सो व्हेन वी अलाउ फॉर इट, लेट मी गो बैक टू द अलाउइंग ट्रायंगल. यहाँ पे आ गए हम बेटा. अब इस ट्रायंगल में यू आर राइट, जो ये एक्स वाई वेक्टर हम लोग बनाएंगे इट विल बी बेसिस द इंजन स्पीड और इंजन डिस्टेंस. यहाँ पे हम जीपीएस डिस्टेंस या डिस्टेंस मेड गुड क्यों नहीं ले रहे हैं, क्योंकि अगर आपने वो यहाँ पे ले लिया फिर तो आपने ये करंट वेक्टर का इफेक्ट पहले ही इसमें लगा दिया ना बेटा. सो उस केस में तो आपको सीधा कोर्स मेड गुड ही मिल जाएगा. अगर आप जीपीएस से ही डिस्टेंस निकाल लोगे और जीपीएस से ही जो कोर्स आ रहा है, जो वो कोर्स दिखा रहा है वो निकाल लोगे, तो हमें सीधा कोर्स मेड गुड वेक्टर ही मिल जाएगा. We will not be required to allow for the current here, will not be required. ये काम तो हम इस केस में कर रहे हैं जब हमारे पास GPS नहीं है. We don't have the GPS. What we have access to is only our gyro, which gives us the course steered, and the Doppler log in deep waters, which is running on water track. यही दो हैं हमारे पास, और हमारे पास ये इंफॉर्मेशन है कि करंट का सेट एंड रेट या सेट एंड ड्रिफ्ट कितना है. दिस इंफॉर्मेशन इज पिक्ड अप फ्रॉम लेट अस से सेलिंग डायरेक्शन और द रूटिंग चार्ट्स. सो उस सिनेरियो में दिस इज हाउ वी आर गोइंग टू फाइंड आउट द कोर्स मेड गुड. अगर हम जीपीएस इंफॉर्मेशन पहले ही ले लेते हैं फिर तो हमें कोर्स मेड गुड फाइंड आउट करने की जरूरत ही नहीं है.
Is it
right?
Clear.
So this is in that particular scenario when you are in deep sea and GPS has stopped, GPS not working, so we do not know what is our course made good and what is our distance made good. We need to find it. So then we use our gyro to find the CTS. We use the Doppler log, which is obviously in deep waters working in the water track mode, to get the engine distance. We check out the sailing directions to get the set and rate of the current, or the routing charts can be used. And using this information, we find out that the vessel will actually be moving on this particular track. So this gives us a good idea where will our ship be after an hour, 2 hours, 3 hours, 6 hours. So we can accordingly steer a safe course.
Sir, in that way, ये तो फिर चार्ट वर्क में जो भी न्यूमेरिकल होंगे ये बेस पे होंगे ना. We are using इंजन डिस्टेंस ऑफ कोर्स.
राइट बेटा, दैट्स राइट. जितने भी क्वेश्चंस हमारे चार्ट वर्क में आएंगे दैट विल बी बेसिकली ऑन द बेसिस कि हमारे पास शिप पे जीपीएस नहीं है. ओके. इनफैक्ट सेल नैव में भी बेटा, सेलेस्टियल नेविगेशन में भी जितनी भी प्रॉब्लम्स हम करेंगे that is basically assuming that we do not have access to GPS. Okay, so We have done the counteracting also.
Maybe 2, 3, 4 degrees. So if we draw,
let me go back a little.
Allow the leeway, or we draw the leeway rather, I'm sorry, we draw the leeway into the wind or to the windward. This is how the leeway will be contracted into the wind, and the track that we obtain is the course to steer track. Now, please remember that this leeway would be a very, very small quantity, maybe 2, 3, 4 degrees. So if we draw both leeway track as well as the CTS track on the chart, it may lead to cluttering of the plot. So if we want, the wind can be allowed or counteracted on answer sheet, and on the chart we can plot and use only the leeway track. So if we want, we could do so, and that shall take care of our requirement.
Okay, so this basically covers up the effect of the wind as well as the effect of the current. So we have seen two scenarios: counteracting the wind and the current, and allowing for the wind and the current. Very, very important topic. So that is done. And with this, basically, we have finished our today's session. So next session, when we meet, we will now proceed to a slightly more complicated topic, that is the position circles. So we will see there are different methods with which position circles can be obtained. So we will discuss them one by one and understand. So that was all from my side for today, beta. See you in the next class then.
Thank you, sir.
Thank you.
Okay, beta. Thank you, sir.
Thank you, sir.